Good morning. So my name is João Souza, and the co-authors of this presentation are Carlos Barrera from Pocan, Federico Ferreira from Forum Oceano, Miguel Bello from the AARC Center, and Michael Jones from TMA Blue-Tech. And so I'll be talking about AARC and also about an idea of mapping the ocean soundscape from oceans to space. So basically, I'll start by describing AARC. So AARC is basically the Atlantic Autonomous Robotics Consortium. The founding partners are TMA Blue-Tech, which is the largest Blue-Tech cluster in the US, Forum Oceano, which is the Portuguese maritime cluster, the AARC Center, and Pocan. And what is AARC about? So the goal is to create and manage a unique set of long-distance testing courses and facilities for use by companies, government agencies, and NGOs from around the world. So you can see it from this picture. Attributes. So we put forward a distributed coordinated operations and support centers in Eastern Atlantic, involving the Azores, Madeira, and Canary Islands, and Lisbon and Porto. And this represents a half-circular arc around the entrance to the Mediterranean. We are talking about 24/7 operations center for data dissemination and vessel communication. We are talking about autonomous underwater, surface, and air vehicles. And of course, we need to promote interoperability across platforms and domains. An important observation is because of the geography, no location is too far to preclude assistance or recovery. We want to test long distance, persistence, and long-term position, residence. And we want to provide access to students, to testing operations, exercises, etc. And this lends itself to the intersection of blue tech and space tech. And this is one of the main reasons why I'm here. Few words about the persistent presence in the ocean. So if you look at this map, you see that there are few robotic centers, existing ones in Porto and Pocan and in Lisbon. There are a few additional planned robotic centers, for example, in the Azores and Madeira Islands. And we are also planning for a 24/7 operations center in the Azores. And the observation is that if you look at the map, distances show that no spot is more than 500 miles from assistance. And this is crucial if you want to have a persistent presence in the ocean in this region. What are we talking about? We are talking about multi-domain vehicle systems for cyanotic persistence. So we are talking about surface vessels, underwater vehicles, and as well as unmanned air vehicles. And of course, we'll need multi-domain control centers, and you see here pictures of a few of those that we've deployed in the past. So we are ready to go. Of course, we are talking about a multi-domain system of systems, SOS, and we want to work towards an interoperable digital ocean framework. So we'll have space, air, surface, and underwater assets. We also played a little bit with the small sets. Of course, we are talking about space analogs. This was already alluded to before today. We are talking about multi-platform observing system of systems, data assimilation tools, FAIR principles, ocean modeling, dynamic downscaling, products and services, end users and society. Keep in mind that two of the founding partners are maritime clusters and blue tech clusters. And this is why we put forward a new organization model and cooperative mindset. A few words about it. So we provide a single point of entry for clients to the AARC network. We'll coordinate closest on-water support and recovery. We'll leverage existing and develop new facilities. We'll coordinate programs across business, internships, operations, testing, training, university outreach, etc. And of course, our ocean observation programs will bridge science and technologies. And we see the Atlantic Ocean as a key element in the triple helix framework: academia, industry, and policymakers. And of course, we'll work on public-private partnership frameworks and pricing to promote cooperation, innovation, and data sharing. And definitely, we'll have a phased technology development programs. So we want to start small and grow healthy. Now, let's talk a little bit about the soundscape of the Anthropocene ocean. So this is a picture taken from this paper that came out recently in Science. And so on the top panel, you see the past, the pristine oceans. In the second panel, you see what we have today, especially in what regards the noise in the ocean. These are very noisy, and definitely there are lots of unintended consequences that we still don't know much about. And from these, we can basically come up with two different scenarios, extreme ones, but it will help us to understand what we're up to. First one, poorly managed future, in which what you see today will be much worse. And second, a well-managed future, in which there will be eventually less ship traffic, quieter propellers, and other initiatives put forward to minimize the level of noise in the ocean. So, but to do that, we really need to measure the levels of noise in the ocean. So we really need to map the ocean soundscape. And this is what we propose. So we'll have different sources of data, of information, starting with remote sensing, SST, SSH, ocean color, AIS, currents, and for example, other products such as finite size Lyapunov exponents that will help us to determine the skeleton of currents. We'll have citizen science providing observations, and we'll have in situ observations that will be performed by our assets that will measure essential ocean variables, sound levels, AIS, pollutants, litter, etc. These observations will feed or will be simulated into ocean models and will also be used as inputs to the production of soundscape maps that will also be informed by ocean models and data assimilation. And from these, we'll derive services for harbor management, for warnings about, for example, mammals. We'll provide recommendations. We will be able to retask the assets in the ocean, and definitely will provide data for the Marine Strategy Framework Directive. And so this is basically what I had to say about AARC. It's a very let's say, ambitious initiative that will produce unique results. I just want to say some final words about this project, SMART, which means Distributed AI System for Marine Plastic Debris Monitoring. So this project won the AI Moonshot Challenge put forward by PT Space. And the project partners are IST from Lisbon, PhilP, where I come from Porto, Instituto Hidrográfico from Lisbon, Aveiro University in Aveiro, and MIT from US. And so we have 4 work packages. The first one is about floating plastic debris identification. So there will be satellite imagery processing. WP2 is about high-resolution numerical models. So, and these will feed into WP3, which is about a physics-guided spatial temporal mapping of occurrence probability. So we'll use machine learning and neural networks to connect these, the developments from these work packages. And finally, we'll have in situ validation, in which we'll use some of the assets that you've just seen, basically to validate what we'll be developing in this project. And so this also provides some food for thought for our project about mapping the ocean soundscape. And this is pretty much what I had to say. Thanks very much. It was a pleasure to be here and to participate in this workshop.